So as we move on, we want to consider other cases of projection apart from horizontal projection. So we really want to consider the general case of projection, which will be at an angle. So not necessarily the vertical or the horizontal, which we've now covered both of. Vertical in year 12, horizontal just now in year 13. So in general, we'll have the initial velocity, and we're going to break it into two components: the horizontal initial velocity and the vertical initial velocity. So those two components we can then use as we've been using elsewhere. All right. We know how to generate these expressions for components using trigonometry in this right angle triangle. So the vertical component is u sine alpha, and the horizontal is u cosine alpha. Okay, let's look at this in context. Okay, so we've been told that the particle is projected from a point on a horizontal plane. The initial velocity is 40 meters per second at an angle of alpha. So just to show this initial projection, I can label this as 40 meters per second, and the angle is alpha. We have, however, been told that tan of alpha equals 3/4. I'll talk about that in a second. Let's break this into components and get an expression for each of these components. So the vertical is going to be 40 sine alpha, the horizontal 40 cosine alpha. Okay, so these are the expressions that we're going to use throughout our working out. But let's be smart about what to do next. We don't really need to find alpha. This statement, tan alpha equals 3/4, is enough for us to deduce sine and cosine of alpha. We know we can produce this triangle with the opposite and the adjacent. Pythagoras lets us know that we have a 5 for the hypotenuse, or we recognize the 3, 4, 5 triangle. And from there, we can get an expression for sine alpha and an expression for cosine alpha. So if we go back to these components, 40 sine alpha is 40 times 3/5. It's an answer of 24. And 40 cosine alpha is 40 times 4/5, which gives us 32. So the initial velocity in vector form is going to be 32i plus 24j. 32, 24, if we wrote it as a column vector. Okay, the point here is that we can produce components for a non-horizontal or a non-vertical projection. So in other words, any projection at any angle, we can find the horizontal and vertical component and make use of that in our problem solving. Okay, so for our next example, we're asked to find the initial velocity, so an initial unknown velocity, and its angle of projection. So we're going to go ahead and we're going to add in our horizontal and vertical components, which are given to us in vector form. So 3i and 5j, let me know the initial horizontal is 3 and the initial vertical is 5. All right, from here, with a spot of Pythagoras, we should be able to find the hypotenuse. We should be able to find u, and u is the root of 34, which equals 5.83. Okay, so now we found the initial velocity, we found u, we found the initial speed. Let's go ahead and find the angle of projection. So once again, we're going to make use of some trigonometry here. So some right angle trigonometry. Tan theta is the opposite over the adjacent, and the inverse tan should give me an angle of 59 degrees to the nearest whole number. Okay, be careful here just to indicate we're talking about above the horizontal. 59 degrees by itself is ambiguous. We might have been thinking of 59 below the horizontal, as in throwing something down. So just to clarify, always state whether it's above or below the horizontal.